Morning and welcome back to the lab. This week we're going to be working with a Diels Alder reaction. It's actually a hetero Diels Alder reaction. So we have our diene and our dienophile, and the diene is going to be standard, but our dienophile, which is our double bond or triple bond, is actually going to be a nitrogen-nitrogen double bond that's contained within a ring. And that's why it's a hetero Diels Alder reaction, because we have carbons with nitrogens coming together. Okay, so we have several things that we have here. We need to prepare our dienophile, however, and so we have this 4-phenylurazole, and I've already pre-weighed this into my round bottom flask, and I put in about 0.85 millimoles of that. That's going to be my limiting reagent in this calculation, or in this reaction, excuse me. I'm running it twice so that in a moment I can react it with two different dienes, and we can see what we get. Then the problem is we're not quite yet at our dienophile. So we need to oxidize this. And you can oxidize in several different ways. You can use just oxygen gas. You can use something like hydrogen peroxide. Or we're going to use something called oxone. And I've pre-weighed my oxone here. So I've got just about 1 gram of the oxone. Okay, so add that together. Organic chemistry is all about adding white powders and getting white powders. So a lot of white here, because unless you have a really long conjugated system for carbon, you don't get the color. However, today we will see a color as we do this. All right? Then we need to add to this 8 milliliters of solvent. We're going to use dichloromethane, methylene chloride. Once again, as always, I'm going to use that to help rinse out any of my leftover starting material. So 5 milliliters. Okay, so we got 8 milliliters of solvent there. Okay. And we'll do the same thing for this one here. 2.5 mils. 2.5 mils. Under 5. Another 2.5. And our last 0.5 mil. All right. We'll get back on that. Out of the way. Okay, and we're going to add this there. Now, a very important thing here is to have very vigorous stirring. So I've got those weather vane micro stirrers. These are 50 mil round bottom flasks that I've got going here. Now, one of the other things we need to add to this is we need to add some potassium bromide. But we don't need very much KBr. Bromine's very heavy. So we need 0.002 grams. It's essentially impossible to measure that small of an amount on the scales that we have. So what we're going to do is we're going to approximate this, and it's just the tip of a spatula worth. Oh, camera's falling over again. There we go. Ooh, that's going to be shaky. Okay, so we're going to put a spatula tip, and I'm talking about just a little bit here, okay, into each one of these. So I got it in this one. Similar amount in this one. This changes the ionic character of our solution and helps our reaction go. Okay, so get this going, nice and vigorous stirring. Okay. And we're going to add 3 drops of water to this. You need to make sure I'm using deionized water. Just a little bit of water. About 20 drops per milliliter, so the idea that we're not doing very much here. 3. Whoa, wow, something's happening. Start to get my reaction to go right away. You'll notice that we get a color change. Okay, that's evidence of our oxidation reaction that's happening. So this will go more and more bright red. So it's not stirring quite as well. Let's get that going. We've got a nice red color forming there. That's good. We want the red color. So we're going to let this stir now for 20 minutes. And then we're going to isolate that compound. So I'll see you in 20 minutes. Okay, welcome back to the fume hood where we do our filtrations. So we're going to do we have a small amount of material, so we're going to use the Hirsch funnels again. And as you can see that after 20 minutes of stirring, we've got this nice red liquid. Now, the material we want is actually in the filter or in the liquid. So we've got some extra of that oxone and the salt and some junk there at the bottom that we don't want. So we need to make sure that these are very clean here. Go ahead and turn this on. And I'm going to filter both of these, and we're going to try to collect the liquid out the bottom there. So hopefully this will work. Okay, so I'll get the vacuum on. There we go. Now we're going to use an extra 5 milliliters of the methylene chloride solvent. All right, we got that over here to rinse out more of our red material. You see, as I do it, the salt kind of loses some of its color because we're getting that red material there. So let's go ahead and put that across the filter. All right. Let that go just for a minute while I do the other one. Okay. Oh, wrong one. Also, if you make sure you use the hose that's actually connected to your flask. There we go. Alright, swirl this thing around. Okay. Again. Shoot this in. What you're seeing here is you're seeing the air being pulled through. Hopefully I won't lose any of my product. This is more vigorous than the other one. Just a little too excited to do chemistry there. And go there. Alright, we got our nice red color. And again, our product, our PTAD that we want, is here in the liquid state. So we're going to take that over to the fume hood, and that's our dienophile, and we're going to react that with 2 different dienes and see what kind of reaction we can get. See you over in the other hood.